In this video, we are going to look at some different ideas surrounding critical thinking and logic. Some of those ideas are going to come from things like sets. So let's talk a little bit about sets. First of all, when we're dealing with sets, we have some special symbols that we need to pay attention to. So first of all, when you see this curved letter E, we are talking about element of, meaning whatever were to come next would be elements of that set. If you want to specify that an element is not a part of a set, you would put a slash through it. So this would mean not an element of whatever set you were discussing. Furthermore, we use what are called braces. They're the little squiggly lines that open and close, and these are how you are going to contain your elements in your set. The last one we need to pay attention to is the circle with a line through it. This means the empty set. In other words, you have a set and this particular set does not have any elements in it at all. So let's say, for example, we want to be able to list the elements of a set, and you're given the following information. So let's say that we're told A is a set of days of the week that begin with the letter S. So there's a few things that we need to take note of. Okay. First and foremost, a set is denoted by a capital letter. So here we would say A is equal to, then we would open our little brace, and the days of the week that begin with the letter S would be Saturday. A comma separates your elements, and then it would be Sunday. Since there's no other days of the week that begin with an S, we would go ahead and close your brace. Okay. So if we take a look at what we have here, A right here is going to be your set. This brace is going to open your elements. Everything in between are your elements. And then this right here is going to close the elements. Okay, and so that's the way a set is kind of built. Now with that, we also have what's called set builder notation. And set builder notation essentially takes a sentence and allows you to build the set without having to identify the elements. So let's say we have that U is the set of all states in the United States of America, and B is the set of all states that begin with the letter A. So what we want to do is we want to build the notation to make this set without having to sit here and actually think about all the states that have the letter A. So to do that, we have to identify the universal, and we have to identify the set we're working with. Okay, so here U is going to represent your universal set. The universal set you can think of as like the big set. It's the one that has all of the information in it. And in this case, we're going to have B is going to be your set. Okay, so this is going to have some elements of the big set. So your set from a universal is essentially listing out parts of the elements that would be in your big overarching set. Okay, so let's kind of look at that. So here what we would have is we would have that B is the set we care about. So B is the set we're looking for. We have to open our brace. And now we're going to identify a variable. So we're going to say X, that's going to represent our element. We're going to use a vertical line, which means such that, and then we have to identify its pieces. Well, first, X is going to be a part of the universal set. So the first thing you have to identify is that your element is going to be a part of the big set. Then you have to state your direction, and X is going to represent all states that begin with the letter A. Since there's nothing else, we can go ahead and close it. So just like before, let's take a look at the information that we actually have here. So B right here represents the set that you want. Okay. My X right here is going to be the element, which is the same as your variable of the set. Okay. This bar represents the term such that. It is the dividing factor between identifying the element of your set and the rule. Okay. Now everything else here is going to be the rule. So essentially this piece here from the bar to the end, this is going to be the rule for the elements. Okay. So the first thing that we did is we had to identify. You have to identify that the element is part of the universal set. The second thing you have to identify is the rule for the smaller set. So we did just that. So we identified that our element was part of the universal, and we identified the rule that we have to follow here. Alright, now another thing that we can do is we can calculate the number of subsets, or what we like to call proper subsets, that occur. So first of all, we have a subset. And when we think about a definition of a subset is all elements in one set are appearing in another set. So if we think about this example that we just did here, where we are talking about U is our universal, it's all the states in the United States, and B is the states that begin with the letter A. So B would be considered a subset of the universal because all of the elements of B are appearing in my universal set or in the other set. Okay, so that's kind of a subset. When we talk about subsets, they have a symbol, and it's this kind of collapsed looking C with a line underneath. Now to calculate your number of possible subsets, we use the formula 2 to the n. And we use that formula because my n here is going to be the number of elements in the set. Okay. So those are subsets. Now the other thing that we have is we have proper subsets. So a proper subset is going to be such that all elements in one set are appearing in another set however the second set has at least one more element. Now again, it also has a symbol, and that symbol is just the simple little squished looking C, or a U on its side, however you want to look at it. And when we go to calculate it, so when we calculate the number of proper subsets, we will use 2 to the n and then subtract 1. So yes, if you look at it, the difference between a proper subset and a subset is you subtract 1. Now again, just like before, this n right here is going to be the number of elements in the set. Okay, so it's the exact same thing. It's still the number of elements, it's just whatever that is, now you're going to subtract 1 away from the value. Okay. So let's say that we have the following. We want to find the number of subsets and proper subsets. And what we're given is we're told that m is equal to x such that x is an even integer and -5 is less than x is less than 5. So that's the set that we're given. So the first thing we need to do is we need to write the set. Okay? So here we would have to find our sets. We're going to open it. We need that x is even and goes from -5 to 5. So here we would have -4, -2, 0, 2, and 4. So in this case, we would have to look at finding n. So if you remember, n is going to be the number of elements in the set. So here, these, we count this up, so here we have that n equals 1, 2, 3, 4, 5. So now we can find our subsets and then our proper subsets. So to find your subsets, remember we're going to do 2 to the n. So in this case we would do 2 to the 5th, and 2 to the 5th is going to give you 32. Okay. Now for those of you who are not familiar with a scientific calculator, here's an example of one. Now obviously this might not be the one that you have, but if I wanted to do 2 to the 5th, I would do 2, and then I would use this little hat button here. It's this kind of, I don't know, we call it a caret, but could be a hat, but you click that and that means power, and then you would click the 5 and hit enter and it'll give you your result. Okay. So remember, when you're working with exponents, it's this little hat button. Now, of course, if your calculator is not the same as mine, you still want to look for this little hat button in whatever calculator you have. Now, to do your proper subsets, again, we're going to look at 2 to the n and then subtract 1. Well, we already know 2 to the n was 32. So this is going to be 32 minus 1, which gives us 31 proper subsets. Alright, now another concept that we use a lot when we are talking about logic is we use the idea between Venn diagrams. Okay, so when we're talking about a Venn diagram, a Venn diagram is essentially comparing two or more sets together. Okay. So, for example, we would maybe have one circle, two circles. Okay, this would be comparing two. And the important information that we have about this is this blue piece right here would be, say, set A. And what's specific about it is that it is going to be only the elements in set A that do not appear in any other set. Okay. Now, with that, I can have, say, this red shaded area over here, and we can call this set B. Now, this is going to be exactly the same. These would be only the elements in set B that do not appear in any other set. Okay. Now, in most sets that we do have an overlap feature. So your overlap, or this orange thing, this right here is called the intersection of your sets. So in other words, this right here, this is going to be all elements that appear in both sets. Okay, so that's your intersection. The intersection is the elements that would appear in, say, both sets. Okay. Now, sometimes you will have a ton of elements that only appear in one set with a very few that combine. Sometimes you will find out that one set is completely combined in another set, and other times you might find out that your sets have absolutely nothing in common. Okay? So for example, if I wanted to make a Venn diagram and I had, say, set A was primary colors, and I had that set B was, I don't know, the color is black and white. These two sets have nothing in common with each other, so we would draw them without linking them together. And we would have that one was set A and the other was set B. And in set A, we would label the primary colors red, blue, and yellow. Whereas set B had the colors black and white. Okay? So your sets or your Venn diagrams don't always have to end up having stuff in common with each other. It's just nice when they do. Okay? So, for example, let's say that we had this question where we wanted to draw a Venn diagram to show the relationship between sets A and B. Now in this case we know that A is going to be the set 1, 2, 3, 4, 5, and B is going to be the set 2, 3. So in order to do that, we would draw our Venn diagram and we would interlock them. And the reason I know we're going to do that is because if you look, set B has the number 2, so does set A. Set B is the number 3, so does A. So you have to label your Venn diagrams with your individual sets. So these are called A and B. The first thing you want to do is your intersection. Okay, so you always want to pay attention and run your intersection piece, so this piece right here. Okay, do this first. And so here we have the numbers 2 and the numbers 3 because they are the ones that are in common between both sets. Once you figure out your intersection, you can figure out what goes in just set A or set B. So here with set A, I've already used 2 and 3. The numbers missing are 1, 4, and 5. And for set B, I used 2 and 3, so there is nothing that goes here. And in this way, now we have the Venn diagram that we needed to show the relationship between sets A and B. Now this is going to start us in on the ideas between or behind intersection and union. So when we're talking about sets, we have two main ideas. We have what's called the intersection, which is going to be only the elements common to all the sets. We use the symbol I don't know, I like to think of it as a rainbow. Some people like to think of it as an upside down N, but essentially this is the symbol we use. Now, when we talk about union, we are talking about all elements in all sets. Doesn't matter if they're in common or not, we're just talking about all of them. Here we also have a symbol, and that symbol kind of looks like a U. So keeping this in mind, let's say that we are given the following. We are told that my universal set is going to be the letters A, B, C, D, E, F, G, H. And then we are told that M is going to be the set B, E, A, D, and N is going to be the set F, A, C, E. Now when we look at these, we can see that M is contained in my universal and N is contained in the universal. So that's how you know that you have a good, true universal set. So let's look at a couple ideas. First, let's try and see if we can find N intersect M. So again, intersect means we want to look for just the letters that are in common between N and M. So if we look at this, I have an F, but it doesn't appear. I have an A, and that appears. So my A is in common and my A is in common. I don't have a C, but I have an E. C is in common and E is in common. Okay. So in this case, when we are talking about the intersection between N and M, we are actually talking about the set A, E. Now, if I want to look at the complement of set M to the intersection of N, we need to know what complement means. So when we're talking about complement, we are talking about this little apostrophe piece. This means complement. So complement of essentially means that you want to look at, or you're going to include, all elements not in that set. In other words, we're looking at the elements that appear in your universal set but do not appear in set M. Okay? So if we look at set M, we'll call set M my orange. And if you look at my universal here, the ones that appear would be B, E, A, and D. That makes up set M. Therefore, my complement, so my complement to M is going to be the set C, F, G, H. Now I want to take this idea and I want to intersect it with N. So I want to look at what letters in my complement show up in N. And so here I have F and C. So the ones that show up together are F and C, F and C. So when I look at my M complement and I intersect it to N, I'm going to get the set of C and F, or F and C, however you wanted to write it. Now, using these same letters, let's look at the union. So let's say instead of the intersection, in this case, I want to look at N union M. Well, again, the union means we are going to include all of the letters that include in both sets, but you only need to write the letter once. So the way that I like to do it is I like to pick whatever my first set is, so face, F, A, C, E, and write that set out in its completion. Then I'll go to the secondary set that I am unioning it with, and I will include the letters that are not already written. So in this case, it would include B and D, and that's my union. Now, I can do the same thing. What if I want the complement of N union to M? So the first thing I have to do here is recognize that once again, this little piece here is the complement. So again, we're going to look at the elements of N that do not appear in the universal. Okay. So with that, let's make M or N my blue ones. And I have F, A, C, E. So the ones I don't have are going to be, sorry, here's F, A, C, and E. So the ones that don't have blue lines underneath them are B, D, G, and H. So here, when I'm looking at my complement, I'm going to have the set B, D, G, and H. Once I know the complement, I can go ahead and union that with M. So here, my N complement union M is going to be everything in my complement set, so B, D, G, H, and then I have to look back up at M and look at what's missing. So I've got the B and the D, I need the E and A. So E and A. Okay, so that is intersection. And union. Alright, another concept that we have a lot to work with are logic statements. So when we're talking about a logic statement, okay, we are talking about, so we're looking at statements. Essentially, we are talking about a sentence that is either true or false, not both. Meaning you can't be true and false at the same time. Okay? Now, a big hint that I can give is that commands, opinions, are not statements. So let's say, for example, I have the statement or the sentence, learning math is fun. Your question asks, or would ask you, so my question would be, is this a statement? Now, when I ask that, I'm not talking about in the English language, because yes, if you were to step into an English class, learning math is fun would be considered to be a statement. But we're looking at this in terms of mathematics. So when I read this sentence, learning math is fun, the first thing I need to ask myself is this a command? Am I telling you to go and do something, like get out of my room? No, this is not a command, but is it an opinion? Well, I would definitely say learning math is fun is a big, huge opinion, because I know quite a few of my students who do not think learning math is fun. However, I think learning math is loads of fun. So here, in this case, your answer would be that no, this is not a statement. Your reasoning, if asked, would be because it's an opinion, and opinions are not mathematical statements. Okay? Now, let's say we had the question or the sentence, Saturday is the first day of the weekend. And you want to know, is that a mathematical statement? Well, first, is it a command? No, it's not telling you to do something. It's not giving you any directions. Second, is it an opinion? Well, no, it's definitely not an opinion. So if you can say no to kind of those types of ideas, then in this case, you would have that yes, it is a mathematical statement. Okay. Now, if you think about it, Saturday is the first day of a weekend is a true sentence. Okay, so therefore it would be a mathematical statement. Now, one of the opposite things that we have to statements is called a negation. A negation essentially means the opposite. So if you have a sentence that says the door is open, well, the negation to that would be the door is not open. Okay? And with negations, we have a symbol. Kind of like this little squiggly line. Okay, could be called a tilde, but personally I like squiggly line better. So it means the negation. So a lot of times what happens is you'll be given a sentence. So you will be given, say, the following: Christmas is in December. And you are asked to write the negation. So the negation essentially means that we're using the opposite. So here, your negation would be that Christmas is not in December. Okay, so notice it's exactly the opposite of what it is that was initially said. Okay, so that's negation. Now, along with this, we have what are called compound statements. So a compound statement this is going to be where you are going to put two statements together. Now with a compound statement, we usually are going to use the words and, or, if then, or implies. And with those we have symbols that we use. Okay? When we talk about and, we use the symbol hat. An or would look kind of like a V. And the if then or implies is a double arrow. Okay? Now we also have the negation, not. And just like with negations, we are going to use the little squiggly line symbol. Okay. Now what we do with this is we've got a couple ways that we look at it. Okay, so first is that you are given sentences. For example, you were told that X means I love to cook, and Y means I hate washing dishes. And then if this is the case, if you're given your sentences first, then a lot of times after that you are given the words. So you are asked to write out the compound. So you would be given X, maybe hat. Okay, so you might be given something like this. Looks like a bunch of gibberish, and what you have to do is you have to take this mathematical here and turn it into the compound sentence. So here this is X, so X is I love to cook. The hat means and, so you would write the word and. The squiggly line means not or opposite. So here if you look at Y, it says I hate washing dishes. So you would write I do not hate washing dishes. Okay, let's keep the two sentences and let's try another one. So what if you were given Y, V, X? Okay. So again, you have to remember Y was I hate washing dishes. So here we would have I hate washing dishes. The V means or, and then I had I love to cook. So we've written the compound sentence. Okay. Let's try one more. So notice here I have my negation of Y. So if Y is I hate washing dishes, again we would have I do not hate washing dishes. I have the double arrow. So remember the double arrow means if then or implies. So there's two ways we could write this sentence. We could write implies I love, love to cook. Or we could have written it as, if I do not hate washing dishes, then I love to cook. Okay, so two ways we could write that if then sentence. Both of those gives you the same idea. Okay. Now, I said there were two ways that you could have been given this information. The second way is that you are given the compound statement. And if that happens, if you're given the compound statement, then you are asked to separate into the variables and write the math, call it math version. Okay, so for example, let's say we gave you, or I gave you the sentence, Superman can fly and Batman is not cool. Alright. So let's say I gave you this sentence. So if you're given the compound, then what you have to do is you have to identify your variables. So we could identify, let's say, change colors here. We've got A and we have B. Now the easiest thing to do with a lot of these is to identify the positive. Or so here we would have that Superman can fly would be my first statement. And then the second one, we would say that Batman is cool. Once you identify your two variables, now you have to write the mathematical sentence. So we started with Superman can fly. Superman can fly was written, so we would have A. My compound is right here, and the and again is going to be the hat. And then my sentence says Batman is not cool. Since I wrote Batman is cool to be my variable, I would have to use squiggle line B. Okay? So if you're given the compound, then they're asking you to do the exact opposite. Alright, the last thing that I wanted to point out real quick is a concept called truth tables. So truth tables is a table that is used in order to evaluate some compound statements to determine if they're true or false. Okay. So a few things to remember. We use the word and. Again, it's the hat. And in this case, you would have true if both are true. We have the word or, which is the V-looking thing. And in this case, you would have false if both are false. Otherwise, it's true. We have the if-then. Again, it's the double arrow. And in this case, you would have false if the first part is true. What it means is if the first part is true and the second part is false. What that means is you cannot go from true to false. However, you can go from false to true. Okay. Now the last thing we have is the negation or the not. And of course we use the squiggle line, and it means the same as the other, which is opposite. Okay. Now we do have a new term that you need to pay attention to, and that term is called tautology, and essentially it means that you have always true. Okay. So how does this work? Well, a lot of times you are simply given a statement. Okay. So we are given, let's say, not X and Y. So we have a column here. We're going to have X and we're going to have Y. And when we're setting this up, usually you're going to be given X and Y. So this would be like true, true, false, false. So this would be the column. And then your Y would go true, false, true, false. So these two columns are generally given to you. It's going to be the other columns that you're going to have to figure out. Okay. So first and foremost, when you're looking at these directions, I have this not right here, which means I need to have the opposite of X. So the first thing that I have to look at is going to be the not X. And not X is going to be the opposite. So I'm looking at my X column here, and I start with true, so the negation of that is false. False, true, true. Now the last thing that I have here is we have the actual compound. So this was not X and Y. So this is where the rules are going to come into play. I am looking only at the not X column, and this is first. Okay, so this is going to be my first column, and then Y is going to be my second column. And I want the and. So remember, and says you're only true if both are true. So we're going to look here. I have a false and then a true. So because I have one false, that makes this false. If you look at the next one, I have false and false. So that's false. Here I have true and true. Both of them are true. That means this one's true. And down here I have true and then false, which makes this false. Okay. Now, this column right here is where you check where you're going to check if you have tautology. So you want this entire column to be only trues. Since this one has falses here, we would say that this one is not tautology. Okay? So if you're asked to evaluate, that's what it's looking for. Alright, so there we go. That, in a nutshell, is everything that you kind of would need to touch base on when you are talking about different ideas of critical thinking and logic. So if you have any questions, let me know. Otherwise, I know this was a very lengthy video. I do hope you made it all the way to the end, and if not, I'm sorry I lost you. Otherwise, I do look forward to talking with you next time.